All right, so now here are some fun questions. I like these. These are great, but some people have a hard time understanding how to solve them. So what we have is we have a system with 3 carts all being pulled by, someone is pulling like a rope or a string or a handle, but they're only applying that force to the first cart, and that first cart is attached to a second cart by a rope or a string between them, and then the second cart is attached to a third cart. All right, so I've made all these carts 3 different masses. All right, we know the force of the pull, and what I'm asking you to do is solve the tension of the strings between the carts and the acceleration of the carts. We're only going to solve for the magnitude because really that's all you need in this question. So what I would like to do is first start doing free body diagrams of all the carts. Okay, so I'll do them here. I'll try and do them underneath one another. So here, this would be cart 3. Okay, so if I look at cart 3, it has one force acting on it. It would be the tension, I'm going to call this tension B. Okay, and it would be to the right. All right, now I'm going to do cart 2. Cart 2. All right, if I look at cart 2, it's got 2 strings attached to it. One going this way to the left and one going to the right. Now, I know they're moving to the right, so this one is going to be longer. Okay, now Newton's third law, all right, is going to apply right here because these are both the same string. Okay, so this force or this tension and this tension are the same. So this is the force of cart 2 on 3, and this is the force of cart 3 on 2. All right, what you have to do is imagine is if this string got cut, both of these forces would disappear. Okay, now this one is, we're going to call this tension A, and that's going to be to the right, and it is the result of that first cart, okay, pulling on it. So here, I'll do 3 hash lines. This is tension, also tension A, but it's pulling backwards on 1. The same exact force is pulling forwards on 2. Now, this whole thing, cart system, is moving to the right or accelerating to the right, and there's no friction. I didn't say that here, but there's no friction. Okay, save that for grade 12. So here, I do know this. We can call this the force of the pull, and I know that is 253 newtons forward. All right, so there are 2 ways to solve these questions, but there's one way that there's one thing that you have to do to get started. All right, so what I'm going to do first before I move on is I want to do F net for each one of these carts. Okay, so F net on 3. Okay, so this is F net, but this is for cart 3. So this equals just tension B. There's no other force acting on it. Well, I could have put normal force and the force of gravity on each of these 3 carts, but I mean, they're going to balance out. It's not moving up or down, and we don't have to do friction in this case, so let's keep it simple. They are irrelevant to this question. So now, F net in this case is equal, has 2 forces acting on it, and it's tension A plus tension B. Hang on a second, my child is calling. I have to pause here. Okay, I'm back. So these 2 tensions are the only forces that are causing the acceleration. All right, and let's do number 1. So we have F net on number 1. So this is going to look like the F of the pull plus tension A. Now these are very general F net equations. If you want, you can put direction into these. And sometimes it's a good idea, but sometimes students get confused. but I can put them in, and then if we put direction, we don't put any signs in afterwards. So if we assume that positive is to the right, what we can do is simplify these. So since this is number 3, this is mass 3 times acceleration, and acceleration is going to be positive, is equal to tension B. And that's going to be positive because it's to the right. So here is our equation for mass number 3. Now I'm not going to put a subscript 3 here for acceleration. I could, but if you think about it, they're all attached. So they're all moving together at the same acceleration. So A3 would equal A2 would equal A1. So there's really no reason to add a subscript there. We can just call it acceleration. All right, so just have 1. So now let's go ahead and do this one. So this is mass 2 times acceleration, tension A. We'll just leave that. Tension A is to the right, okay? And tension B is to the left. So minus tension B. So what I'm doing is I'm not putting vectors on these because I am considering to the right positive. This negative is because this is to the left. This TB is to the left. Let's go ahead and do this one, F net for number 1. So that's going to be M1 times acceleration. And the F pull is 253 newtons to the right. And then my tension A is to the left, so minus tension A. I cannot simplify that anymore. So here's my 3 equations of Newton's second law for each of these carts. Now when you look at this, I don't know, like if you looked and see, what do you know? Well, you know M3, M2, and M1, but I don't know acceleration. Okay, so I need to figure out how can I solve for one of these variables. I'm kind of stuck. And this is the next step where it's kind of intuitive. What you do is you squish all the masses into one. So call this M1 plus M2 plus M3. And that force of 253 newtons is applied to all of them together as one unit. So what I'm doing is I'm essentially treating this as 1, and what happens is you have just made the 2 tension forces we've just made the tension forces internal forces. So they're kind of irrelevant to the question when I squish this all together and make this one mass. And what happens is when I take this equation, the Newton's second law for this system, what I get is F net equals M, I'm going to call this M total A. I know F net because the only thing acting on it is this 253 newtons. The mass total is these 3 masses added up. And so I can solve for the acceleration. Okay, so the acceleration ends up being F net over mass total. I'm going to go to the right here so I have enough room to finish my question here. So F net is 253 newtons to the right, and my mass total is 45 plus 27 plus 18 kilograms. So I'm going to put that on my calculator. 253 divided by, and I'm going to add these up, 45 plus 27 plus 18, close a bracket. Okay, I get 2.8111 repeating. Okay. So what I get is my acceleration. Oh, I asked for just the magnitude. The acceleration of the carts is approximately 2.8 meters per second squared. Okay. This is newtons per kilogram. Hopefully you're getting the hang of that. That's meters per second squared. And I'm still going to keep this number because I'll need it later on to do my questions. But right now I did figure out the acceleration. And don't forget, this is the acceleration for all the carts. Now that I know this, zip back over here. Now when I look at this equation, I know the mass, I know the acceleration, I can solve for TB. Once I know TB, I go here. Because I know the mass, I know the acceleration, I have TB from that, not tuberculosis, but the tension B here, and I can solve for tension A. And actually, then I'm really done because I don't even need this last equation here because I've already found tension A. There is another way to solve this question, putting them together, but this is the best way that I like, and so let's do that. So solving for TB, okay, that's equal to M3 times A. And M3, if I go up here, is 45 kilograms. The acceleration is 2.8111 meters per second squared, and that's also going to give me newtons. So I go ahead and take this, which is your calculator, take 45 times 2.8111, and that's going to equal 126.499 newtons, okay? So tension B is approximately equal to, I can only have two significant figures because my mass is only two significant figures. So that's actually going to get rounded to 130 newtons because this 6 is greater than 5. And finally, to solve for TA, I'm just going to write the right side first. Okay. Now I have to rearrange this because I'm solving for TA. So what I'm going to do is I'm going to add TB to both sides, and I get M2A plus TB. And then I'm going to talk about this equation. Well, let's talk about it now. So does it make sense that I'm adding these? Because originally I was subtracting them. Well, I want you to think about what is causing this tension here. This tension, okay, has to cause the acceleration plus work against the tension created by being attached to another mass, okay? So this is the acceleration plus working on pulling the cart. So imagine if the cart string got cut, TB, all of a sudden, this is what tension A would be. But since that cart is attached, we need to have that extra force there. So M2, make sure you're using the right masses, 27 kilograms. The acceleration is still the same, 2.8111 meters per second squared, plus TB, and TB is 130. No, it's not. You use the unrounded value, 126.499, and that's newtons. So take your calculator. Okay, 27 times 2.8111, okay, if you want to add another one, equals, and then I'm going to add 126.499, and there you get 202.398 newtons. But you're going to round that to two significant digits, okay, so tension A is going to be approximately 2.0 times 10 to the power newtons. If I had just written 200, that'd only be one significant digit. So if I'm being super picky here, which I should, all right, there is the question in its finality. Now, like I said, there's other ways to do this. If you're interested, I just find it's easiest to work from left to the right. There's no reason that I need to use this one now. Now, could I use this one? Sure. I wouldn't even need this one here. I could have skipped over this and just solved for TA using this equation because I knew M1 and M1 and acceleration of mass 1. So if you want, for fun, which you should, it's so much fun, take this equation, put an M1 and A, and add TA to that, subtract 253 from that. You should get the same value for TA whether you use this equation or this equation. And don't forget to pay attention to this negative when you're rearranging. Okay? So try that. You should get the exact same number within rounding. Okay? Bye-bye, enjoy, and talk to you soon.